Now recall from section 4.2 that if f has a local maximum or minimum at a value of c, then c must be a critical number of f by Fermat's theorem. But not every critical number gives rise to a maximum or minimum. We therefore need a test that will tell us whether or not f has a local maximum or minimum at a critical number. Now you can see from the graph of example 2 that we have a local maximum at 0.5. So there is a local max. Okay, and then we also have, and you can see that the local maximum of the value, because the function increases, so the green here, we can see that it's a local maximum because it's increasing from the interval from -1 to 0. Okay, and then you can see that it decreases on 0 to 2. So from 0 to 2, we can see that the function is decreasing. Okay, so again, here we can see that it is increasing, and then over here it's decreasing for the function. Okay, now in terms of the derivative, okay, well, we can see that again here that the purple represents f prime of x. So what is happening between the interval for f prime of x between -1 and 0? So we also know that the derivative of this function is increasing. So it's increasing for the function, and it's above 0 for the derivative function. Okay, likewise, in between the interval between 0 and 2, okay, we can see that the function is decreasing, which tells us that the derivative function in between 0 and 2 is going to be less than 0. Okay, so in other words, the sign of f prime of x changes from positive to negative at 0. So from here, you can see at 0, it went from positive, and then it changed to negative here. Okay, so this now is going to give us the following test. So the first derivative test, suppose that c is a critical number of a continuous function f. If f prime changes from positive to negative at c, then f has a local maximum at c. So you can see here that it changed from positive to negative, and so therefore we ended up with a local maximum. Okay, now if f prime changes from negative to positive at the value of c, then f has a local minimum at c. And if f prime does not change sign at c, then for example, if f prime is positive on both sides of c or negative on both sides, then f has no local maximum or minimum at c. So the first derivative test is a consequence of the I-D test. Okay, I divided by D test. In part A, for instance, since the sign of f prime changes from positive to negative at c, f is increasing to the left of c and decreasing to the right of c, and it follows that f is a local maximum at c. It is easy to remember the first derivative test by visualizing graphs such as these below. Okay, so here we can see that the function in blue is increasing and then decreasing, okay, which then tells us that the derivative here is going to be greater than 0, and the derivative here is going to be less than 0. And so therefore, if it's changing from positive to negative, then this tells us that we have a local maximum at c. Okay, so now if we take a look at the next graph, we can see that the function is decreasing here and then increasing there. Okay, which means that the derivative is going to be less than 0, so we have a tangent line that is decreasing, and then over here we have a tangent line that's going to be increasing. So again, it's changing from negative to positive at C, and if that is the case, if it's going from negative to positive, then what we have is a local minimum. Okay, so again, it's important to notice this. Okay, so from negative to positive, it's a local minimum. From positive to negative, we get a local maximum. Okay, now over here, okay, what we can see here, there's no maximum or minimum because of the fact that it's increasing, the function is increasing on the left and it's increasing on the right, which tells us that f prime, or the derivative, is greater than 0, and it's greater than 0 here. So therefore, since they're the same sign, it's positive and positive here, there's no maximum or minimum at the value of C. Okay, and likewise, on the left side here, it's decreasing, so we know that the derivative is less than 0. On the right side here, we can see the derivative is less than 0, which is also negative. Now, since it's the same sign, it does not change at C, okay? And therefore, what it's saying here is that this also does not have a maximum or a minimum value.